All right. I'm going to cover Cramer's rule in this video just because it's something that's going to be useful. We use this in circuits a lot, but I think if some of you have seen on your statics homework, you've got some three equations, three unknowns, and they become a little unwieldy to operate. So I have this system of equations, linear equations. I've got X, Y, and Z are unknowns. I've got these coefficients. So what Cramer's rule says is you can take this, Cramer's rule doesn't say this, but you can take this and you can write this as a matrix. And, I think this is something that people do in pre-calculus, but I can't remember for sure when you learn this. So I can rewrite this whole thing as a matrix. I've got 25 minus 5 minus 20 minus 5, 10, and minus 4, minus 5, minus 4, and 9. That's my matrix. This is my matrix of coefficients. And then I multiplied that matrix by X, Y, and Z. Right, and that equals, we've got our solution, solution matrix here, 50, 0, 0. These are the answers to these equations. So this is a form A X equals B, right? Where these are matrices, A and B are matrices. Well, they're all matrices. And what Cramer's rule says is that each X can be found if you take the determinant. Well, I got to explain this a little bit. The symbol for determinant is I, the determinant of a matrix. So this is the determinant of A. And delta I is the determinant of A with, so for example, I equals 1, you replace column 1 with the solutions. So let's just, let me just walk through this. And let's see, you know what? Well, let me calculate the determinant of matrix A first. And what I'm going to do to calculate the determinant is, you've probably seen this technique. I'm just going to rewrite the first two lines here. 25 minus 5 and minus 20 minus 5, 10, and minus 4. And the way the determinant works is you go along these diagonals. You multiply 25 times 10 times 9, and you add it to minus 5 plus minus 4, or times minus 4 times minus 20. Plus minus 5 times minus 5 times minus 4. Then you subtract off the diagonals in the opposite direction. So minus 20 times 10 times minus 5. Let's write this out and see what it looks like. So the determinant of A we're going to have 25 times 10 times 9. So let's do the math here. 90 times 25. We've got 2250 plus, I'm going to take minus 5 times minus 4 times 20. So we've got 20 times 20, but it's a negative, right? Because we got negative, negative is positive, times a negative is a positive. So we've got plus a negative 400. And then we've got 5, 5, and 4, right? So 5 times 5 is 25. Add there's a positive 25 times 4 is 100. This is a negative 100. Then we're going to subtract off the diagonals in the opposite direction. So basically, this way is positive. And then the other way is negative. So let's take minus 20 times the minus, 10 times the 5 is 50 times the 20, right? we're going to get 1,000, but we're going to get a negative, or let's see, we're going to get a positive. So we're going to have a minus 1,000. Then we're going to have a minus, let's see, we got 25 times 4 negative, right? This gives me negative 100, but we got another negative. So we're going to be 400. Oops, let's use red here. What did I say, 400? I'm remembering these numbers. See, plus, minus, minus. All right, then we're gonna have one more minus, going from 9 times 5 times 5, negative. Well, these two negatives cancel out, they become a positive. So you got 25 times 9, 225. So the determinant of A is equal to, I'm gonna add these up here. So it should be 2250 minus 400 minus 100 minus 1,000 minus 400 minus 225. Yeah, this is 125. That's the determinant of A, 125. Now what I do, let me adjust my brightness here. A little better. Now what I do is I take this matrix, and for the delta I replace each column. So for I equals 1, I'm replacing column 1 with the solution matrix here, with the matrix B, basically. All right, so I'm going to write these out. Delta 1 is going to be, we're going to, instead of the 25 minus 5 minus 5, we're going to have 50, 0, 0. And we're going to have minus 5, 10, minus 4, minus 20, minus 4, and 9. And I'm going to go ahead and rewrite these top two rows down here so I can do my my determinant. All right, so now I'm left with a matrix where I can solve for the determinant. This is delta 1. We're going to have, notice here, 50 times 10 times 9, right? So 50 times 10 times 9, that gives us 4,500. And then here we got a 0 and a 0. So that's plus 0 and then plus 0. And we're going to have a minus 0, right? 20 times 10 times 0. Here we've got 16 times 50, right? So we're going to have a minus 800. And then here we're going to have a minus 0. So again, just drawing the lines this way, plus, right? It helps to draw the lines or circle it or something so you can tell, keep it straight, or just be very neat when you're creating the matrix. Right. So delta 1 is equal to, let's see, 4,500 minus 800, 3,700. Yeah. And I'll do one more. I'll do delta 2, and then I'll just show you what delta 3 is. So delta 2, we're going to do the same thing. So now we're going to replace the second column with the B matrix. So I've got 25 minus 5 minus 5. I've got 50, 0, 0. And then I've got minus 20, minus 4, minus, oh wait, it's not minus, it's a positive. I'm going to rewrite these again down here. First row. And again, you'll be able to see here, these zeros are really helpful, right? This is a 0. This is a 0. And this is going to be -5 times -4, which gives us a +20. I'm going to write these in. 0 plus 0 plus. So yeah, 20 times 50. What's that? So that's 1,000. And then the other direction, I've got a -0, right? -0. And then a 9 times 5 times 50, -5. So this is a minus. Let's just put the zeros in for placeholders. And then let's see, 5 times 50 times 9 times 5, then you give us 2250. It's a minus of a minus though. So we're going to have a delta here of 3250. All right, delta 3 you can do on your own. I'll just tell you what it is here. It should be 3,500. So now x is just equal to delta 1 over delta. And this is going to be equal to 3,700 divided by 125. It's 29.6. Y is just delta 2 over delta. That's going to be 3,250 divided by 125. It's 26. And then Z is going to be delta 3 over delta. And that's 3,500 divided by the 125. 28. Now, of course, you can take these numbers, and ideally you would. You take those numbers and you plug them back into your original formulas, right? You check your answer. Rather than spend time on that, I also want to show you a feature of a lot of graphing calculators. Well, some graphing calculators, I don't know. My particular calculator allows you to actually set up and solve simultaneous equations. So I'm just going to show you that. And then I'm also going to show you the matrix functions. So, I mean, if you're okay with Cramer's rule at this point, you don't have to watch any further, but I'm going to go ahead and do this just for the sake of showing you. All right, so on my function or my calculator, I have second and simultaneous. This gives me, so I'm going to tell it I have 3 equations, and I'm going to set up the coefficients. This is for each equation. So notice you've got x1, dot, dot, dot to x3 to b. So this is how we've set up. This is based right off of the generic matrix A times matrix X equals matrix B, right? I'm going to go ahead and fill out my first matrix, which is the 25, the -5, the -20, and that equals 50. And this is taking me right to the next. Once I hit enter on my calculator, it takes me right to the next equation. Next equation is -5 plus 10 minus 4, and that equals 0. And then the third equation is -5 minus 4 plus 9 and 0. And I always like to double check this because sometimes I forget negative signs. 25 minus 5 minus 20 minus 5, 10 minus 4 minus 5 minus 4. All right. And then for me, all I have to do is hit solve, and it gives me the answers. So it solves them for me. 29.6, 26. And you can see x1, x2, x3 are just my x, y, and z in this case. And you can see that's the same answers we got before, right? 29.6, 26, and 28. Now, if you don't have the simultaneous equation solver, you probably do have matrices in your calculator. So let me show you. I've got a little button called matrix. So I'm going to hit the second function, matrix. And I'm gonna, now I don't have any matrices in there. So I'm gonna edit and create a matrix. I'm gonna call this matrix A. And I make this a 3x3 matrix. Now, the way this is set up is in columns, column 1 and column. So if I can scroll back and forth between columns, it gives you the. So I'm going to put my matrix in here. Oops, I forgot. It takes me. I like to go vertically. Now, if you hit enter on my calculator, it takes you right to the next. Takes you sideways. So this is my first column. Minus 20, or sorry, 25 minus 5 minus 5. Go to my next column. I'm going to put in minus 5, 10, minus 4. And then there's minus 20, minus 4, and 9. Now, what I'm going to show you here is I'm not going to do matrix calculations with my calculator other than the determinant. I'm just going to create the matrix A, which I just did. Minus 20, yeah. I'm going to exit out of here. Now I'm going to go back to the matrix functions, and I'm going to take the determinant of A. Right? And that's the determinant we got when we took it by hand, right? 125. So I can quickly get the determinant of a matrix with my calculator. And what I can do is I'm going to take and copy A into 3 other matrices. So I'm going to make matrices B, C, and D. And I'm going to go in and I'm going to edit these matrices. I'm going to edit matrix B. And I'm going to replace, I'm going to do what I did here. I'm just going to replace each column, right? In matrix B, I'm going to replace the first column with the solution matrix, right? The B matrix. So in the first column here, I'm going to write 50, 0, 0, right? And now I can take the determinant of that $3,700, right? And that's the determinant I got for the first matrix, right? When I replaced the first column. So there's a quicker way to do this if you have matrices in your calculator. You can readily replace those columns. You don't even have to use any of the other math functions. So I'm going to edit matrix C here, and I'm going to go to the second column. I'm going to do the same thing, 50, 0, and 0. Took the determinant of C, and I've got 3250, which is, again, I replaced the second column with the B matrix, and I found the determinant. I did the same thing on my calculator. And then we can do the, I think you believe me now that, oops. Go to the third column here, put a 50, a 0, and a 0 in. Okay, the determinant of D, and you get 3,500, which is, well, that's what I told you it was. I didn't actually do the solving. But that's how you do it. And then you just use the, Cramer's rule, knowing that the determinant of, if you replace each column with the, let's see, if you read this in a textbook, it tells you delta is the determinant of the matrix A, and delta I, right? Delta I is the determinant of the matrix form when you replace the ith column of A by B. That's all we're doing. So that's Cramer's rule. That really helps you solve simultaneous equations. Now, there are programs that can do this. MATLAB is one of them. There's free versions of MATLAB. You could set up, setting up a spreadsheet may not be the best idea, but A lot of graphing calculators have matrix functions, and that could be a powerful tool. I'm going to pause the recording here. All right, the only other thing I want to show you is if you do have a calculator that does matrix math, you could set up matrix A and B. And let me show you how that's, and then just solve by taking the inverse. So you could take A X, right, equals B. These are your matrices. And I'm writing these out with brackets just to indicate their matrices. And you can find X. Now in matrices, we don't divide, we multiply by the inverted matrix. And you may have learned how to do a matrix inversion, I think, again, in pre-calculus. And this is basically the same as the inverse of matrix A times matrix B. And let me just show you here what I've done. So I've still got matrix A in here, right? Matrix B, I've put in is just a single matrix, right? So we got 50, 0, 0, so single column matrix. Right, that's our matrix here. And then I'm going to take the inverse of A. You can see what that becomes. And I'm going to multiply that by B. And that gives us the same solution, right? So you get X equals, what do we got, 29.6, 26, and 28. So yeah, that's handling matrices. Obviously, there's a lot more you can learn about matrices. This is a fairly rudimentary stuff, but Cramer's rule is very useful. All right, thanks for watching.